Hi everybody, today we're going to go over synthetic division. Synthetic division is a shortcut to long division. However, you can only use synthetic division when the divisor can be written in the form x minus r. So if you cannot get the divisor to be written in x minus r format, then you would have to use long division. So different ways to write division. So obviously you can write division using the elementary division symbol. You can also use to the -1. That is just, this is really just the same thing as writing this. So with negative exponents, you can undo the negative exponent by bumping it down into the denominator. That is one of the rules of negative exponents, to write the reciprocal. We're not going to get into that division rule, but just FYI, aka also known as, right? That's just another way to write that. And then obviously this also means division. And then we have the very, very elementary division symbol. And let's go over some vocabulary words. So the number that's in the denominator goes outside, and that is called the divisor. So this is the divisor. And what you're dividing into is the dividend. And your answer would be the quotient. So whatever you get out as your answer, that's going to be the quotient. So just a little bit of vocabulary words. So let's look at that x minus r format. Notice to be x minus r format, notice that it has a degree 1 and that has a coefficient of 1. So it has to be in that format in order to use this thing called synthetic division, which that's what our lesson today is synthetic division. So let's take a look at some problems and see which problems we can use synthetic division with. If you look at problem number 2, notice that it has an exponent of 2. So therefore, this one would have to be done by long division. You would not be able to use synthetic division. Problem number 1, notice that the divisor is in the x minus r format. Here, the r would be -4 in this problem, because couldn't you write that as x minus a -4? So see, it can be written in the x minus r format, where r in this problem would be -4. And let's look at some more examples. So before we go through with synthetic division, let's just review dividing by a monomial. Notice how these are monomials. That means you have a single term. So those ones you're not going to do long division. You're just going to divide into each term divided by 2km squared. And then 12k cubed m squared and 2km squared. Getting a little messy. So you're just dividing each term by 2km squared and simplifying. So when you simplify this one right here, and I'm going to put it over here, you get 3, and the k in the bottom cancels out with the k on the top, so you end up with the k in the numerator. So we got to see where things are left over. So we're left with a 3 and a k in the numerator, because this k is going to cancel out with one of these k's, and one of these m's is going to cancel out with one of these m's. So you're left with an m in the denominator. And then minus, now we're going to look at this one. 2 goes into 12 6 times, right? And this k is going to cancel out with one of these, so doesn't that leave a k squared? And m to the second power divided by m to the second power cancels out, or another, really, any number divided by itself is 1. So m squared divided by m squared is 1, right? And now we're working on this one. So 9 halves does not reduce, so we're just going to leave it as 9 halves. And then don't these two m's cancel out with these two m's? So doesn't that leave me with an m in the numerator, and don't I still have a k in the denominator? So that's how you do dividing of monomials. But remember, today our lesson is really on synthetic division. So let's look at some of the divisors. So in this problem, the divisor is f plus 2. Do you see how that is in that x minus r format? Here the r would be -2. So in this case, the r would be -2. Look at the divisor here. Do you see that it's in the x minus r format? So here we could use synthetic division. So these ones we could use synthetic divisions if we wanted to instead of long division. Here the r would be positive 4. So right now we're practicing identifying the r and noticing whether you can or cannot use synthetic division. So let's look at a couple more. So here we have on number 11, if we look at the divisor, which is x plus 4, so we're looking at these divisors, correct? So let's look at a few of these divisors. So if we look at this divisor, it is in the x minus r format. So therefore, we could use synthetic division and the r would be negative 4. Here it is in the x minus r format, so we could use synthetic division and the r would be negative 3. Number 15, the r would be positive 5. And remember, this is just a fancy way of saying all of this is being divided by x plus 2. So that's just a fancy way of saying the same thing. And what would the r be in this problem? Negative 2. Now here it is not in the x minus r format because it has a coefficient. So we're going to look at that one later. And if we can get it into the x minus r format, then we could use synthetic division. And those are harder ones. So for right now, we might just say just use long division. But I am going to show you on the last two problems how we can get that into the x minus r format. And if we, same thing with this one. So because it has a coefficient, we're going to use long division. But there is a way to actually get that into x minus r format. And again, I'll go over that one later. Other than that, you might want to use long division. This one is a squared, you have no choice. This one you must use long division because it has a squared. Okay, so let's do some problems on synthetic division. Okay, so this is going to be weird at first. So notice that the problem is using with the -1 exponent. Remember, that's just a fancy way of writing this. So it's just another way of writing division. And what is our r in this problem? Right? Correct. The r is 6. So what we're going to do is, it's going to seem really weird, we're going to make a backwards L, and in place of where that, in that little cubby hole, we're going to put what the r is. And remember, the r in this problem is positive 6. So our r is going to go in that little cubby hole. And then what we're going to do is write the coefficients of the dividend. Remember, the dividend is the numerator, and we're going to write the coefficients. So notice that we have a coefficient of 1, and then we have coefficient of -5, -8, 13, and -12. So we're going to write the coefficients 1, -5, -8, 13, and -12. So we're writing the coefficients. And that's what we're going to write here. It's good to see that word coefficient, so you're using that word. We're going to leave a little bit of space, and then we're going to draw a little line in between the last two. And whatever we get here is going to be the remainder of the problem. Remember when we did long division? That's going to end up being your remainder. So basically what we're doing is, we're not really doing long division. We're doing kind of a form of it where we're not having all those variables in there. We're just kind of taking the variables out. Whoever comes up with this, I don't know. It's crazy, huh? Okay, so so that's how you set it up. So here's how it works. You always want to bring down the first number below the bar. I'm going to call this the bar. And then you're just going to multiply, add, multiply, add, multiply, add, multiply, add. So we're going to multiply whatever the r is times whatever we get down here. And that answer is going to go above the bar. So 6 times 1 is 6. And now we're going to add. So it's just multiply, add, multiply, add, multiply, add. We're going to put our answer, -5 plus 6 is 1. And then we're going to go back and multiply 6 again times this 1. So 6 times 1 is 6. And then we're going to add. So it's just multiply, add, multiply, add. So it gives me -2. And then 6 times -2 is -12. You got to really watch your integer skills. And then 13 plus, remember we're adding those. That's going to give me a 1. And then 6 times 1 is 6. and then negative 12 plus 6 is negative 6. So our remainder is negative 6. So that's our remainder. So this is what's called the depressed polynomial. So since we had started with an x to the fourth power, that means when we put our variables back in, they're going to go back in with as 1 degree less. So since we started with a degree 4, in other words, the exponent was 4, that means when we put our variables back in, that's going to be x cubed, x squared, x, and then no x's. So when we write our quotient, remember the quotient's the answer. So write your answer completely out. Don't leave it like that. So your final answer should be written nice and neat outside. And then it's a negative 6, so we're going to put minus 6 and then over the divisor. Now remember, this isn't the divisor. Remember, the divisor was really x minus 6. So x minus 6. So that's the answer you should get. It's really weird. You might want to pause the video. You might want to rewind it. Try it again yourself and go through it again. So let's look at this again. So here we have where the divisor is in the form of x minus r, where the r is negative 1. Therefore, we can use synthetic division. So we're going to do a backwards L. We're going to put our r in the little cubby hole, whatever you want to call that. Right? So we're going to put our r in that little location. And then remember the coefficients go here. Now, you have to use fillers. So what do I mean by fillers? Notice that this is a degree 5. So it's a 5th degree. So that means we have to have each degree below that. So we have 3m to the 5ths. We have no m to the 4ths, no m cubed, no m squareds, and then we got 1m, and then we have a negative 1. So let me write this out so you can see it better. We have 3m to the 5ths. We have no m to the 4ths. We have no m cubes. We have no m squares. We do have 1m, and we have a minus 1. Do you see the 1m right there? So these are called fillers. So you must put fillers. So even if there's no constant, you'd have to use a 0 as a filler for the constant. So we needed all of these fillers because remember, we're just writing the coefficients of the variables. So we have to, right? So we're just writing the coefficients. And that's where these came from. So you have to watch out, make sure you got all your fillers in there. So now we're going to start the process. So now that you know how to set it up and you know about your fillers, and you know that you have to look for those fillers and add those fillers, remember we're going to leave a little bit of space. And then we're going to draw a little line in between the last two. And remember, this is always going to end up being your remainder. We love when the remainder comes out to be 0. We'll talk about that later. So remember how it works. You're going to bring down the first digit. And then you just multiply, add, multiply, add, multiply, add. Negative 1 times 3 is negative 3. 0 plus negative 3 is negative 3. Negative 1 times negative 3 is positive 3. Add, you get 3. Negative 1 times 3 is negative 3. Add, you get negative 3. A lot of 3's in this problem. Sorry, negative 1 times negative 3 is 3. And then 1 plus 3 is 4. Yay, finally something different. Negative 1 times 4 is negative 4. And then when you add that, you get negative 5. So remember, we started to the 5th power. So that means when we put the variables back in, this is going to go back in as 1 less. So this is called the depressed polynomial. It ends up being 1 lower than the degree that we started with. So since this was a 5th degree here, this is going to be m to the 4th, and then m cubed, then m squared, and then m, and then no m. So our final answer is going to be 3m to the 4th minus 3m cubed plus 3m squared minus 3m plus 4. That's right there. That's that plus 4 minus 5 over, and then remember our divisor was really m plus 1. So that's the lots and lots and lots of terms on this one. Okay, so let's look at one that doesn't have so many 3's going on. Okay, let's move this one up. Okay, so what is our r in this problem? -2, correct. So we have -2 as our r. That goes in the backwards L. And then, do we need any fillers? Did you say no? That's correct. No fillers, because we have a cubed, a squared to the first term, and then a constant. So we're good. We don't need any fillers. So the coefficients are -1, +2, +5, -4. Notice how I left a little bit of white noise in between the coefficients so that I can leave some room in there so it's not so squishy. So make sure it's not so squishy. And remember, this is going to be your remainder. I'll just put r period. So leave a little bit extra space. Remember how it works? So why don't you pause the video and try this one on your own and then put it back in. Okay, so let's see how you did. So did you bring down the -1? And then it's just multiply, add, multiply, add, multiply, add, which is different from long division, because long division, you're multiplying, subtracting, multiplying, subtracting, multiplying, subtracting. Synthetic, it's multiply, add, multiply, add. So -2 times -1 is +2. 2 plus 2 is 4. -2 times +4 is -8. And then when you add, you get -3. And then multiply, -2 times -3 is +6. And you add, you get 2. We're going to go back in and now put our variables back in. And since we started with a degree 3, that means it's going to come back as a degree 1 less. So x squared, x, and then no x. You cannot just circle that and say it's your answer. You've got to rewrite the original answer nice and clean with all your symbols. And then it's a +2, so we're going to say plus 2 over, right? 2 divided by, because that's your remainder, and our divisor was x plus 2. So that's your answer. So that's the easy synthetic division ones. So let's look at some harder ones that we could if we want to use synthetic division. Okay. Okay, so on this one, you could just do long division, but remember, to use synthetic division, we have to have it in that x minus r format for the divisor. And notice our divisor is not in that format. But we could get it to look like that by doing the following. If we divided the denominator by 3, as long as we divide the numerator by 3, let's see what happens. So that would give us, in the numerator, that would give us 2x cubed plus 5/3 x squared, don't freak out, minus 2/3 x plus 1/3. So if I divided the numerator, isn't that what I get as my new numerator, which is my divisor? My dividend, sorry, it's my dividend. And when I divide this by 3, don't I end up getting x minus 1/3? See, now I have it in the x minus r format, where the r is 1/3. And so this is why some students are like, yeah, never mind, I'll just use long division. But sometimes the fractions aren't that hard. So let's go through it and see how it is. But if the fractions are really freaking you out, you can just go, nope, I'm just going to go back and do the long division, right? Okay, so we're going to put our coefficients. Do we need any fillers? Right, we got the coefficients. We're going to have some fractional coefficients. We don't need any fillers because we have a cubic, a squared, to the first degree, and a constant. So we don't need any fillers. So we've got a 2. We've got a 5/3. We've got a -2/3. And we have a 1/3. Make sure I didn't make any recopying sign errors or anything like that. So we leave a little bit of space. Remember, that's where our remainder is going to be. And then we're just going to bring down the 2. And then 1/3 times 2, right? 1/3 times 2. Can we put a 1 underneath that? Don't we just multiply the numerators, multiply the denominators, and that's 2/3. We should be able to do that in our head. So that's 2/3. And when you add 2/3 plus 5/3, isn't that just going to be 5/3 plus 2/3? It's going to be 7/3. And then when you multiply, well, I guess maybe I did pick a hard one. And when you multiply, oh, I guess I did. Let's see. Did I make a mistake? 6 divided by 3 is 2. 5/3. Yep. Negative 2/3. Yep. 1/3. Okay. So I picked a hard one. Okay. So I just want to double check. Yep. 7/3. So then we have to multiply 1/3 times 7/3. So that gives you 7/9. So when you add that, that gives you 7/9. And then we're going to get common denominators. So we're going to make this negative 2/3 and 7/9. We're going to change this to ninths. And you already tuned me out, didn't you? Multiply by 3, that's negative 6. So it's negative 6/9 plus 7/9 gives me 1/9. And then we're multiplying. Hang on, let me erase. I feel like I did something wrong. I may have done something wrong. It's usually not that bad. Okay, so then we got to multiply 1/3 times 1/9. So 1/3 times 1/9 is 1/27. And then when you add 1/3 plus 1/27, don't I want to make my denominators 27ths? So that would be multiplying by 3. So that'd be 9/27 plus 1/27 is 10/27. And I really think I did something wrong. So I may have copied the problem down wrong and made it really, really icky. Let's see. I have a funny feeling I copied the problem down wrong because it shouldn't be that awful. So I'm going to leave that one. And I have a funny feeling I maybe did something wrong on that one. Maybe I copied part of the problem from one to the other. But that's basically how you would do it. So let's look at number 5. Let's see if I... Oh, I did. This was supposed to be a plus. So if we go back, let me start over. This was supposed to be a plus. So let me go back over with that. Okay, so my mistake was when I recopied this problem down, I didn't recopy this as an addition. I recopied it as a multiplication or as a subtraction. So when we divide everything by 3, that's what we get. So now our r is not 1/3, but our r is negative 1/3. And then our coefficients are still 2 and 5/3. And normally they're not that bad if we give you problems. I mean, they could get, but we normally don't give you some that are that crazy, right? So again, we bring down our 2, and then we're going to do 2 times negative 1/3, right? Just multiply straight across. So that's going to give you negative 2/3. See, that's not so bad. And then negative 2/3, so a positive 5/3 and a negative 2/3, when you add them, gives you 3/3, right? 3/3, and isn't 3/3 just 1? So 3/3 is just 1, so we're going to write 1. And then negative 1/3 times 1 is just negative 1/3. So a negative 2/3 plus a negative 1/3 is a negative 3/3, and that's just negative 1. And then negative 1/3 times negative 1/3 is positive 1/3. So 1/3 plus 1/3 is 2/3. Okay, much better. Not so crazy after all. Okay, and then we're going to go back and fill back in our variables. So we're going to put our variables back in. Remember, we started with a cubic. So that means it goes back in as 1 degree less. So x squared, x, and then no x's. So our final answer is going to be, it's not really our final answer. I'm going to write it down here. Is 2x squared plus x minus 1 plus, because the remainder is a positive, 2/3 is the numerator, and then remember we were dividing by x plus 1/3. So we were dividing by x plus 1/3. And then in the mathematical community, we don't like to have fractions within a fraction. So we do not agree to have a fraction within a fraction. So we're just going to go back. Remember how we divided by 3? We're just going to go back and multiply both by 3. Remember, that's really just multiplying by the number 1. So we're not changing the value. We're just making it look different because we're really just multiplying by the number 1. And that's just going to make it look different but not change the value. So we're going to go back and undo the division by going back and re-multiplying. And when we do that, the 3's cancel out and gives you just a 2. And when you multiply through by the 3, you get 3x plus 1, which is what we had before. So that's how you do those problems. So some of you might just go, yeah, nope, I'm just going to go back and do long division, which that's your choice if you'd rather do long division. But let's try another one. So in this problem, number 5, remember it's not in the x minus or r format. So we can get it to be in the x minus r format by dividing by 2, and therefore we have to divide these by 2. And when we divide by 2, that's going to give me 2p to the 4th minus 17 halves p squared plus 7p minus 3 halves, all divided by p minus 3 halves, right? So that's what you get. And so what's our r going to be? It's not negative 3 halves. Our r is positive 3 halves. And then our coefficients are 2, negative 17 halves, 7, and negative 3 halves. Did we need any fillers? Oh, we did. There's a p cubed missing, isn't there? Oh, gotta go fix it and put those fillers in there. So you always got to look for those fillers. Notice that there is a p to the 4th power, p squared, p to the 1st power, a constant, but there's no p cubes. There's 0 p cubes, so we have to have 2 and then 0 for the p cubes, and then negative 17 halves for the p squareds, and then 7 for the plain old p's, and then negative 3 halves for the constant. So you gotta double check and make sure that you don't need any fillers, or that you have the fillers if you need them. So let's bring down the first digit, 2. So when you multiply 3 halves times 2, can't you put a 1 underneath that? Can't you cross cancel? And doesn't that just give you 3? 0 plus 3 is 3. When you multiply 3 halves times 3, doesn't that just give you 9 over 2? So that's 9 halves. Thank goodness these have common denominators. So isn't that negative 8 halves, right? Negative 9 plus not negative 17 plus 9 is negative 8 halves. And isn't negative 8 divided by 2 negative 4? So shouldn't we replace this with negative 4? And then 3 halves times negative 4, right? Doesn't that cancel out and leave you negative 6? And then 7 plus that's positive 1. And then 3 halves times 1 is 3 halves. And doesn't that give you a 0? Thank goodness. So our remainder is 0. And our final answer is, now we got to go back in and put the variables back in. So because this started with the 4 cubed, right, it was raised to the 4th power. So that means our coefficients and our variable is going to go back in as an x cubed, and then an x squared, and then an x, and then a constant. So please rewrite your answer one last time with all the symbols there written correctly. I'm not going to accept it. I'm not going to accept you just circling this and throwing in some plus signs in there. That's not acceptable. So this is your final answer. And there was 0 remainder. So that's your final answer. So that's synthetic division.